Something incredible is happening in 2026 that most people aren't talking about. While everyone focuses on Artemis 2, NASA is quietly orchestrating the most ambitious lunar mission schedule in over 50 years. We're not just talking about 1 or 2 missions here. 4 separate lunar landing attempts are planned for this year alone, each carrying the potential to reshape our understanding of the Moon and accelerate humanity's return to its surface. What makes this even more fascinating is how SpaceX has become the backbone of this entire endeavor without even deploying their own lunar lander. Through strategic partnerships and proven launch capabilities, they're enabling a lunar renaissance that could determine who controls the future of space exploration. China isn't sitting idle either, and the competition for lunar dominance has never been more intense. Today, we're diving deep into each of these 4 missions, examining their unique objectives, the technology they're testing, and why their success or failure could influence space policy for decades to come. By the end, you'll understand why 2026 might be remembered as the year everything changed for lunar exploration. Let's start with Griffin Mission 1, a project that perfectly illustrates how quickly priorities can shift in space exploration. Originally designed to deliver NASA's Viper rover to the lunar South Pole, this mission underwent a dramatic transformation when budget constraints forced the removal of its primary payload. Viper was supposed to be a game-changing robotic explorer, specifically engineered to hunt for water ice in one of the Moon's most strategically valuable regions. Despite losing its star passenger, Griffin 1 remains scientifically significant. Built by Astrobotic Technology, the same company behind the Peregrine mission that launched in early 2024, this represents a critical redemption opportunity. Peregrine's journey ended in disappointment when thruster malfunctions prevented lunar arrival, but those failures provided invaluable engineering data that directly influenced Griffin 1's design. The mission is scheduled for launch no earlier than July aboard SpaceX's Falcon Heavy rocket. This choice of launch vehicle isn't accidental. Falcon Heavy provides substantial performance margins and proven reliability, crucial factors when targeting the challenging lunar South Pole environment. The South Pole represents the future of lunar exploration, offering potential access to water ice deposits that could revolutionize space travel by providing both life support resources and rocket fuel ingredients. Without Viper, Griffin 1 will deploy an alternative rover called Flip, weighing approximately 450 kilograms. This 4-wheeled explorer is specifically designed for navigating the treacherous terrain around lunar polar regions. Alongside Flip, the mission carries Astrobotic's Cube rover and various smaller commercial, scientific and cultural payloads, ensuring the mission delivers meaningful scientific value despite the payload changes. The importance of water ice discovery cannot be overstated. Future lunar bases, whether American, Chinese or international, will likely concentrate around the South Pole specifically because of these potential resources. Water isn't just essential for human survival, it can be split into hydrogen and oxygen, creating breathable air and rocket propellant. This capability could transform the Moon from a distant destination into a stepping stone for Mars exploration and asteroid mining operations. Griffin 1 serves as a pathfinder for human missions, testing landing technologies and gathering environmental data that will influence how future bases are constructed and operated. With SpaceX providing launch services and Astrobotic applying lessons learned from previous attempts, this mission carries significant potential for advancing American lunar capabilities. Our second mission showcases the power of persistence in commercial space development. Intuitive Machines is preparing IM-3, their 3rd consecutive lunar landing attempt in as many years. This Houston-based company has already achieved what many thought impossible, successfully landing 2 spacecraft on the lunar surface in 2024 and 2025. Though both missions experienced post-landing challenges that limited their operational capabilities. Both previous missions used the Nova C lander design and launched aboard SpaceX's Falcon 9 rocket, establishing a proven partnership that continues with IM-3. While the earlier landers tipped over after touchdown, they still transmitted valuable data and demonstrated that commercial lunar delivery is achievable. IM-3 represents an evolution of these experiences, incorporating design improvements aimed at achieving stable surface operations. The target destination for IM-3 is the Reiner Gamma region, located on the Moon's near side within Oceanus Procellarum, one of the largest basaltic plains visible from Earth. This location offers unique scientific opportunities because Reiner Gamma exhibits mysterious properties that have puzzled scientists for decades. Unlike typical lunar features, Reiner Gamma appears as a swirling, high albedo pattern stretching roughly 70 kilometers across the surface. Most intriguingly, it's associated with localized magnetic fields that create complex interactions with solar wind and space weather. Scientists still debate how these features formed, making IM-3's investigation potentially groundbreaking for understanding lunar geology and magnetic phenomena. The mission will carry magnetometers and plasma sensors as part of NASA's Commercial Lunar Payload Services program, designed to leverage private companies for cost-effective scientific delivery. Understanding how magnetic fields affect lunar dust behavior, radiation exposure, and surface charging could prove critical for future crewed missions. Equipment design, habitat placement, and operational procedures must account for these electromagnetic environments to ensure astronaut safety and mission success. Intuitive Machines enters IM-3 with more practical lunar landing experience than most competitors. Combined with SpaceX's continued launch support, there's growing confidence that this mission will achieve stable landing and deliver meaningful scientific results that benefit both commercial development and NASA's Artemis program. The third mission represents perhaps the most strategically significant undertaking of 2026. Firefly Aerospace's Blue Ghost 2 mission targets the lunar far side, a region that has never been reached by an American spacecraft. This achievement would mark a crucial milestone in the ongoing competition with China, which has already established multiple successful far-side operations. Firefly earned this opportunity through exceptional performance with their first Blue Ghost mission in early 2025. When that mission achieved a fully successful lunar soft landing without major anomalies, it demonstrated that American commercial companies could deliver reliable lunar access. Building on this success, Firefly again selected SpaceX as their launch partner for Blue Ghost 2, scheduled for the second quarter of 2026. Operating on the lunar far side presents extraordinary technical challenges, primarily because the Moon itself permanently blocks direct radio communication with Earth. Traditional mission control becomes impossible without relay satellites or alternative communication methods. Firefly's solution involves deploying their Elytra orbital transfer vehicle, which will position the European Space Agency's Lunar Pathfinder orbiter to serve as a communications relay during surface operations. Beyond communication challenges, the far side holds immense strategic and scientific value. China's successful far side missions have demonstrated significant technological capabilities while gathering exclusive scientific data from this previously unexplored region. American access to the far side would provide crucial scientific insights and establish a foundation for future crewed missions that might operate in this challenging environment. Blue Ghost 2 will carry diverse international payloads, including the United Arab Emirates Rashid Rover 2, wireless power transmission technology developed by Voluta Space, and various NASA instruments under the Commercial Lunar Payload Services program. This international cooperation demonstrates how commercial missions can advance multiple nations' space objectives simultaneously. From a strategic perspective, Blue Ghost 2 represents America's opportunity to demonstrate technological parity with Chinese far-side capabilities. While China reached the far side first, detailed environmental and operational data from this mission could enable rapid American progress if crewed missions eventually target this region. Success would also validate the commercial lunar payload services approach for exploring previously inaccessible lunar territories. Our fourth mission stands apart from the others in several important ways. Blue Origin's Blue Moon Mark 1 represents the only major 2026 lunar mission not launching aboard a SpaceX rocket. Instead, it will debut aboard Blue Origin's New Glenn rocket, marking a significant test for this new heavy-lift vehicle and demonstrating growing diversity in American launch capabilities. Unlike the primarily scientific missions we've discussed, Blue Moon Mark 1 focuses on technology demonstration and validation. Its primary objective involves testing critical landing technologies, including navigation accuracy, guidance systems, and thruster performance that will be essential for future cargo and crewed missions. This represents a different approach to lunar development, prioritizing technological maturity over immediate scientific discovery. The lander is designed to carry up to 3 metric tons of payload, substantially more than the other missions we've examined. One key payload is NASA's SCALPS instrument, which stands for Stereo Cameras for Lunar Plume Surface Studies. This technology will analyze how exhaust plumes from landing thrusters interact with the lunar surface, providing critical data for future missions that must land safely near existing infrastructure or sensitive equipment. Blue Moon Mark 1 targets the lunar South Pole, the same region that Griffin 1 and China's Chang'e missions are investigating. This convergence isn't coincidental. The South Pole represents the most strategically valuable lunar real estate due to potential water ice deposits and favorable conditions for establishing permanent human presence. This mission serves as a proving ground for Blue Moon Mark 2, a crew-capable variant currently designated for Artemis 4 and potentially Artemis 3, depending on program developments. Together, these missions mark a critical bridge toward renewed human lunar landing capabilities after more than 50 years of absence. The broader implications of Blue Origin's approach extend beyond individual mission success. By developing independent launch and landing capabilities, they're creating redundancy in American space infrastructure while challenging SpaceX's current market dominance. This competition could accelerate technological development and reduce costs across the entire industry. Even without developing their own lunar lander, SpaceX remains absolutely central to America's 2026 lunar efforts. 3 of the 4 major missions rely on SpaceX rockets, demonstrating the company's unmatched combination of reliability, flexibility, and cost-effectiveness. Falcon 9's exceptional success rate and Falcon Heavy's flawless mission record have established SpaceX as the preferred launch provider for high-stakes missions. However, expectations for SpaceX extend far beyond current capabilities. The company's Starship human landing system remains critical for future Artemis crewed missions, but its development depends on successfully demonstrating orbital refueling, advanced thermal protection, and rapid reusability. Progress on these technologies will largely determine whether NASA can maintain its current Artemis timeline and compete effectively with emerging Chinese capabilities. The competitive landscape extends well beyond American efforts. China's Chang'e 7 mission, also targeting the lunar South Pole in 2026, highlights the intensifying international competition for lunar resources and strategic positioning. The South Pole's importance stems from its potential water ice deposits and suitability for long-term human presence, making it the likely focal point for future lunar colonization efforts. This concentration of activity around the South Pole creates both opportunities and challenges. Multiple missions operating in proximity could enable collaborative scientific efforts and shared infrastructure development. However, it also raises questions about territorial claims, resource rights, and operational interference between competing national programs. The outcomes of these 2026 missions will reverberate through the space industry for decades. Successful commercial missions will validate NASA's strategy of leveraging private companies for lunar delivery, potentially accelerating development timelines and reducing costs. Conversely, multiple failures could force reconsideration of current approaches and delay human return to the Moon. Technology demonstrations from these missions will directly influence Artemis program decisions, international partnerships, and commercial space development strategies. Data gathered about lunar resources, surface conditions, and operational challenges will shape how future bases are designed, where they're located, and what capabilities they require. The international implications extend beyond traditional spacefaring nations as commercial companies demonstrate reliable lunar access. Smaller countries and private organizations may gain unprecedented opportunities to participate in lunar exploration through payload purchases and partnership agreements. Looking ahead, 2026 represents a critical inflection point in the new space race. The breadth of participants reflects a deepening and increasingly competitive aerospace ecosystem where success depends not just on government funding, but on commercial innovation, international cooperation, and technological risk-taking. Whether America maintains its leadership position in lunar exploration will largely depend on how these 4 missions perform. Success could establish American commercial companies as the preferred providers for international lunar missions, while validating NASA's public-private partnership approach. However, setbacks could provide opportunities for Chinese expansion and challenge American technological credibility. The stakes couldn't be higher. Lunar exploration represents more than scientific discovery. It's about establishing the foundation for humanity's expansion throughout the solar system. The technologies tested, partnerships formed, and precedents established in 2026 will influence space exploration for generations. As we monitor these missions throughout the year, remember that we're witnessing history in the making. The decisions made, risks taken, and achievements accomplished will determine whether humans return to stay this time, and which nations lead humanity's next great adventure among the stars.